if you were necessarily say it was a lot of the actually thinking about it.
That would be great.
So to kick off this panel discussion, what I'd like to do is to invite each one of our panelists to just say a few words about what they think of as the relationship between philosophy of science and history of science. And I put up on the overhead one view of that relation, and you can comment on that if you like, agree with it or disagree with it, but it's not obligatory. So, Curtis, will you start?
We'll try. I'm not well read in philosophy of science, but I always have a certain interest in pragmatic aspects of astronomy, by which I mean cases where it's not all that clear how to go. One has to find a way. I think Brown felt he really ought to study Poincaré, and so he did spend he was asked to give lectures at a meeting at Cornell in 1900 of the Mathematics Society, and he decided to lecture on Poincaré. And he really gave himself a hard time because it was not friendly, familiar territory to him. And he chafed a lot because Poincaré made mistakes in proofs, not trustworthy. Actually, I'm sorry to say we don't have a decent translation of Poincaré's work on celestial mechanics. But anyway, he tried, and I haven't followed all that through. He gave lectures and wrote back to George Howard Dolan that it had gone pretty well, but there was too much he couldn't manage. I think he finally decided that his job was to try to do as best he could with the calculations. He didn't. There was some sort of, I don't know how this relates to philosophy of science, but he was very late in coming to the notion that the Earth's rotation was non-uniform. Physicists like Kelvin, like Eddington, like Joseph Larmor, when they saw that term, that great empirical term, they immediately said, it's the Earth, and then started thinking in those terms. Gradually, Brown came around, but he always tried to think about some cause of whether how things worked. And the solution actually came with Jones letting causality slide and simply establishing from the observations that the same thing was happening with the moon and with Jupiter, but it produced terms. Well, that's all I'll say. I'm interested in studying the peculiar special circumstances that history reveals sort of in relation to scientific questions. But I don't have philosophical theory.
I'm in a complicated situation, but I want to preface it with a point that didn't come up this morning that this audience may be unaware of, just from the Kantian source of the quote. The first person to propose in a published paper that I know of that the reason the moon was accelerating was that the Earth is slowing down because of a tidal bulge, and it was Immanuel Kant in the 1750s.
I did not know that.
It was ignored by the scientists, but it's very much present. It's exactly the right model, and qualitatively. After it was actually proposed in the 1860s following Adams, what actually happened here, he made the story brief. Laplace did this wonderful job of giving the secular acceleration of the moon with first order accuracy and ignored the second order terms. And Adams put them in and found half of it went away, and now he had a half to account for. It took 60 years to verify that with tidal, and it's actually Harold Jeffreys is one of the two people who succeeded in verifying that in the 1920s for his work. Anyway, now let me go to the book. I'm in an extremely embarrassed position because a paper is about to appear in Modus that was invited as the to initiate a conference on the question what should the relation of history of science and philosophy of science be. This is the whole Modus issue is on this topic that's about to appear. And I didn't know Russ Hansen had ever said this. And so I used it, but I used it with very qualified ways. So that's what I'll do in responding to it. In the paper, I argue philosophy of science is empty without history of science. For the following reason, it's a specific form of history of science, I argue. And you heard a little bit of it today. I'll say it now in a way that clarifies who I am, a great deal sitting next to this man. A long time ago, I read a paper of his that's formed the basis for all my subsequent work and my so-called famous Newton course. Simply called From Kepler's Laws So-Called to Universal Gravity Empirical Considerations, right, or empirical factors. And it was the first time I had seen anybody actually look carefully at what I now call the history of evidence rather than the history of concepts. And my training is that of an engineer where I work very, very extensively with evidence. And that paper convinced me everything I had read in philosophy of science was beside the point for the following reason. Philosophers seem centrally concerned with our having some criteria for accepting theories that in some way that I've never been able to comprehend makes them more likely to turn out true than not. And every time any historian has ever looked at initial acceptance of a theory, the one thing that's transparently obvious is the evidence is woefully weaker at the time people started predicating research on it than it was subsequently. And that's what that paper of his drove home to me. So everything I've done since then is trying to develop a concept of studying the history of evidence, which means continued testing, not the initial evidence, but what happens after a theory becomes, I don't like the word accepted because I think it's a source of confusion, after people take a theory to be true and predicate research on it and require something really strongly anomalous to back up and reconsider. And that's going on all over the place. So the principal argument I'm offering is philosophy of science is blind, empty, because it's looking at the wrong place for the evidence. The evidence is in the subsequent research, in the example I gave today. In the continuing molecular research has provided much more evidence, I'm going to argue, for quantum theory than anything that Heisenberg, Schrödinger, Born, and Jordan could possibly have offered in 1927. And the same is very much true for Newton. The history of celestial mechanics has offered much more. So I have a line on that. Now I have to go back when the proofs arrive, which may be this weekend, and get Northwood Russell Hansen. I need to know the source so I don't make a fool of myself. Let me do the other half. Why is history of science empty? Well, the other half of the paper is the talk is attacking Chapin and Schaffer. And it's essentially, the argument is, you're sitting around saying philosophers don't understand, the evidence is very weak when theories are initially accepted in science, and therefore they can't possibly have the epistemic status to claim. And they're simply blind to the fact that there's a continuing history of that. So, just using my example, Leviathan and the Air Pump ends with 1680. Pneumatic research didn't stop in 1680. It's still going on at the present moment. So why stop in 1680 and draw the conclusion science is really just another form of humanistic activity with all the people? So I stupidly subscribe, put this forward as a theme of a talk, trying to convince both philosophers and historians of science for a rapprochement, and a rapprochement centered on actually studying the history of evidence.
What George said. I feel at a disadvantage if you just finished writing a paper on this very subject. So I'm going to approach this from a slightly different direction, from a much more personal direction. I first got interested in the philosophy of science when I knew absolutely nothing about either topic, and I wrote a history and philosophy of science paper trying to figure out how you would go about determining whether or not the theory in the philosophy of science actually was correct, and could use historical case studies in order to do this. And of course, what I found was that you couldn't really say anything if you didn't use real history. So if you used cartoon history, which often happens far too often, then you aren't going to learn anything in the philosophy of science. So when I arrived at Western and came in contact with Bill and his work on Newton, and also as a result of coming in contact with Bill, reading works by everyone that I'm sitting with right now and seeing how history is actually done properly, when you're actually going to look at the history of evidence, use George's phrase, then you learn things about philosophy of science that you couldn't learn otherwise. You simply couldn't. And I'm trying to figure out how to convey this. When you see a philosophical problem in its historical context, there's a kind of persuasiveness that it carries that it doesn't in when it's in the abstract as well. And I think that's really important to pay attention to that. So I've just been focusing on why philosophy of science needs history of science, but I think I'm going to leave it there and pass the ball on.
Well, I guess I disagree with the letter, but agree with the spirit. I mean, history of science without philosophy of science is blind. Nonsense. I mean, that's a piece of hubris from the philosophers of science, right? That only we can identify the interesting and important problems. And if that's the idea, I think it's wrong. Philosophy of science without history of science is empty. Well, that's also wrong. We have plenty of counterexamples of interesting work in philosophy of science that doesn't make any contact with history of science. But I certainly agree with the spirit of the quotation. I think both history of science and philosophy of science are more fruitful when they're brought into contact. Now, exactly how you blend them or bring them into fruitful contact, I don't really have any theory of that. All I can do is point to some successful exemplars. Bill's work, George's work, and so on. Other than pointing to successful exemplars, I don't have any theory about how you go about it. Do you have a theory from your long career? That's not a rhetorical question. This is a chance to get you to say.
I guess maybe I should for us and Lee more and others. And Boss was trading on a trade-off between strength and security. And he was saying, look, I'm just accepting the empirical consequences. So I'm just being more cautious than you guys. And the mere consequences of the theory, sense of consequence of the theory, have to be at least as probable, usually more probable, right, than the theory. So you had this trade-off. And I heard it like, in our APA meetings, I think I went to, in 1 year, I heard it at 3 different, I went to all 3 APAs that year. And that came up every time in these fierce debates, and Boss would have this trade-off. And it struck me that there was something illegitimate about the trade-off. I mean, if you're only measuring security by probability, then of course that you're forced into it. And so I think it might have been Clark that set this up, but there was a meeting at Wayne State that had Clark. I was supposed to comment, and Dan Garber, and we were the main. I put it down. I was in the middle of doing decision theory stuff, but I was asked to give a title, and I said my title is going to be consilience, security through strength. Consilience induction and Newton's argument for universal gravity. I knew the consilience a bit from Buell. And I'm still busy doing this other stuff, right, on conditionals or whatever it was. And it was getting, closer and closer to when I was going to have to actually talk about this. And I actually started to read Newton's argument for universal gravitation. And I sat down and read in book 3, those, even the first 6 propositions, and just, wow, it was so much more powerful, than the sorts of hypothetical deductive, you just assume something and got. And I was just blown away by the strength of it. And moreover, I was, there was okay, that's a sort of, and ever since, I've been trying to do justice to how much more powerful the actual, that kind of argument, it took me a while, but I'm now right on board with George. The initial argument, even powerful as it is, it's nothing compared to the incremental kind of support that comes from the succession of applications, for example, to the solar system in the long term. But it did seem so much more powerful, and I wanted to get clearer on where this was coming from and understanding it. It seemed to me there was way more source for high-quality evidence in the practice of science than the stuff that philosophers usually talked about would do justice to. And that's been sort of one of the things that's been occupying me ever since. So.
Can I add 2 points to that? Same thing with Jack. I'm trained as a philosopher, I'm trained as an engineer. I was not trained as a historian until Bernard Cohen started teaching me how to do it. But I just tell everybody who hasn't done it, it's amazing the discoveries you make when you start doing it. There's just a huge amount of material out there. You heard 2 names today that most of you probably haven't heard, Spencer Jones and Dennison. They're very similar people, although Dennison became a famous person at the University of Michigan. Spencer Jones was actually his royal astronomer at the time he did it, so he had even more standing than Dennison ever had. But you discover these people who've done these phenomenal pieces of evidential reasoning to really secure major steps, and they're really excited. That's comment 1. Comment 2. However much philosophers don't know about the history of evidence in physics, let me assure you, physicists know less. Get out of their lifetime and they haven't got a clue of what the evidence is, because it's not taught in any course. There's not even a semblance of evidence taught in any science course I've ever seen, other than Steve Brush's.
I want to do, because I'm at a conference, I was at a conference, it wasn't Marcel Gross, it was some honoring, at any rate, I was at a table with a bunch of Russian physicists, and they all knew the computer, they all read it.
Krylov.
I was just amazed. I mean, these are physicists, right? Not, you know, and it was astonishing.
But a
And so I
major-
want to say that there might be a difference between
There's a reason
North
for
America
that.
and
The translation into Russian was by one of the major physicists of the
okay.
period 1900 to 1930, Krylov, who was so revered at the time. And when he got late in life, he just started doing Newton. To this day, the best paper on Newton on comets is by Krylov, standard paper. So I think that can make a difference when a really major physicist jumps in and translates it.
You can just jump in. Yeah, go ahead.
Okay. This panel discussion is too friendly, so I'm going to say some curmudgeonly things.
A little louder, there's a
Okay, this is too friendly, so I have to say something that's out of step. So there's a presupposition here that it's either philosophy or history or nothing. But I mean, science has changed in character since the 17th century. There's statistics, there's machine learning, there's a kind of interdisciplinary amalgam of things that has resulted in computer software that scientists actually use in the laboratory and trust. So some of these nuances and judgments that we talk about historically under the guise of Newton are actually quantitatively encoded in software that people are using to search for models, and not just scientists, but in finance, in business, in medical industries, in advertising. And so I'm wondering why is the quotation here from Hansen about history as being the way to inform philosophy of science, rather than people who are actually doing these things for scientists in a normative way on the table where it's formalized and could be studied directly.
I mean, maybe the problem is more that it's the history of science without science is blind, and philosophy of science without science is empty. That seems that almost tautological. And I mean, I know in my department at the University of Toronto, most of it was the tradition. I believe it's slightly less true in the past couple of years, that the students tend to be people who've done their undergraduate work. We're a graduate institution. We only graduate students. Well, we have a couple of undergrads, but it's not encouraged. And most of the graduate students have a background in some science before they begin their studies at HBS. And so perhaps that's the more of the takeaway than the need for historical and philosophical laws.
Well, and also, when we talk about history, presumably we don't have to mean history is something that occurred
Yeah.
at least 50 years ago or earlier. So we're talking about a historical view of theory, so it can happen all the time. But I take your point.
Can I go back to the first, about science changing over time? It's an anecdote, some of the people in the room know the paper. I gave a paper at the Howard Stein Fest that Sam Schwaber decided to circulate all over the world, telling me first. And I got a lot of responses from people, but the one that moved me most was by Fierst, who must be very old now, was in German and had to be translated for me. But what it said was, Smith has shown that Newton knew how to do science the way we do it now. And that made me exceedingly happy. But now let me do the other thing. I think science has changed. I want to make a proposal. And it came up beautifully in Curtis's talk. Usually the problem in doing science is gaining access to something we don't have access to. And in the history of orbital astronomy, what we didn't have access to was the distance of any object from here. The first time we got it at all was Copernicus's theory, because it allowed theory-mediated triangulation of those distances. You can't do it without it. But it was only theory-mediated. Now, thanks to lunar laser ranging and radar, we've eliminated the mediation of orbital theory to that axis. I would like to suggest, look at place after place. What has happened where science has progressed is to gain more effective access to something you didn't have before. And the prime example of it all is Newton gaining access to the physics out there. But in that sense, I think it's changed, but I'm not sure the problem has ever changed. Because as far as I can see, the problem constantly is the same thing. How do we gain access to something we don't have easy access to? Sorry.
I didn't say that the method changed. What I was saying is that now there's stuff out there that people are using.
Oh, I understood what you said. I wanted to jump on and use your statement for another moment.
I want to pick up on something that George said earlier about most physicists not really knowing what having to prove such evidence. And that happens for pedagogical reasons. So you take your first quantum mechanics course, there's an introductory chapter about some experiments, and then you have to learn how to use formalism. And what it doesn't do is go through what you did today. And an awful lot of the real evidence for quantum mechanics is the detailed, quantitative, stuff having to do with molecular spectra and acidic heats and things like that. And it's this rich, interwoven, complicated tapestry that you just cannot present in the introductory chapter of a physics textbook. And I think what happens is once people start to look a little bit at the real things, it leads to skepticism. I think that's what happened with guys who wrote the Bow Laboratory, Collins and Finch. Is that they had this. You have this textbook view where you have these few crucial experiments, and that decides everything. You go back and look; it's more complicated, and then it seems, well, what the way I thought was working doesn't work, therefore it doesn't work. And I think if physicists don't really know about evidence, it's so much the more true of the people in the general public, and I think that that's a real problem. I think part of the reason that the creationists are able to make such headway is that when people were talked about in the first place, they were just taught, here's what you're supposed to think, and they weren't really taught what the evidence was. And I think it's also because a lot of people in the general public don't have a good sense of what scientific evidence works. It gives the climate change skeptics a foothold. I was at a conference a couple weeks ago talking to Lenny Smith, who's a statistician who studies climate models. He's in Toronto this weekend for Models and Simulations, and he said to me at dinner, it's your fault, meaning you philosophers of science, meaning, not me specifically or anyone different, but whoever, in the division of academic delivery of labor, whose job is it to convey to people how scientific evidence works? Whoever's job it is to do that hasn't been doing a good job, and I do take that to be true.
By the way, physicists do know remarkable amount about the evidence in the area they've done research in.
Right. Yeah.
I mean, they can recall it all. Just take them a little bit out of that area, though, they don't have a clue.
I'd like to submit a comment for further comment. Here's something I found very instructive in my philosophical education. A large or a good portion of that education has consisted in studying various rational reconstructions by philosophers of certain areas of science, mainly certain areas of physics. Without naming names, these rational reconstructions have departed from the actual history of whatever branch of science, but in case generally physics. This is something I found invaluable.
Any comments? What's the role for rationally reconstructing the parts from the history?
Well, I'll find.
Okay.
I guess my view is that when I hear these beautiful, rich presentations from the history of science, I greatly appreciate it, and I can't do it. So I'm entertained by it, and I'm edified by it, and a lot of interesting things happen. But from my point of view, maybe a problem of the sort that's just been discussed is that compared to the history of science, compared to the science itself, the ideas that have been thrown at understanding science and what its point is are quite rudimentary.
Quite what?
Rudimentary. That we really haven't, there's been a lot of repetition of some basic ideas, but there hasn't been enough attention in the sort of mathematical structure, interesting mathematical structure of potential models of what science is about, what connects the means to the ends, what makes it effective, the kind of stuff that would be routinely done in other areas like computability, right? I mean, there you really have to explain the methods you're doing. You have to justify them with some kind of theory. You don't just say it feels good or it's rational. I think there's really room for that kind of thing on the philosophy of science side that would sort of draw out and explain aspects of the history. One thing that sort of jumps out at me in the histories that we heard today, that are rather sort of similar in this respect, is the crucial role of not understanding what a theory really predicts, right? I mean, the central role of the approximations, how a lot depended on empirical projections of how sequences of approximations would come out, especially in Professor Wilson's piece, right? That's really interesting, right? Because we've got uncertainty about mathematical deductions that are on the table. So from a certain philosophical point of view, you're obligated a priori to know what the outcomes of those will be, right? That's the ideal Bayesian setup. And so I think the history...
That's the caricature of the
Well,
Bayesian setup.
It's the ideal character.
well, I mean that's where the foundations come from. So I mean I'm happy to hear what the normative basis of the approximations is. But I think the history really does enjoin us to tell that kind of story in detail, right? I mean the history is saying let's make that a sort of central aspect of our explanation of what's going on in science. But then there it is, right? I mean it's time to do some kind of mathematical modeling work about what could possibly be the foundation of those kind of inferences. And then at that point, sort of I would say the philosophical topic can be detached to some extent from more details of a similar kind.
Can I respond?
Yeah, absolutely.
Yeah, 3 responses, 3 points I want to make. First of all, what Bill and I have been doing from the day we met one another, which is around 1990, is trying to show that the hypothetico-deductive picture of evidence in science is incredibly understates the evidence in science. And it is the source of most of the anti-science movement, and has been for a long, long time. And I continue, you agree with that, I trust, Bill, but that's what we've been doing.
But it was 87.
No. Comment number two, philosophers, I think I've now come to feel, and I was careful about it, though I don't know if anybody heard it, they're very, very sloppy when they refer to the theory. Typically what you have is a generic theory, which is a set of laws that by themselves you can't do anything. Newton's laws and the law of gravity are totally useless for anything. What you learn with problems in the back of a chapter is how to use them, very often doing more approximate systematic dependencies, etc. And it's separating those two is another thing that philosophers just gloss over. And I want to say a last thing. It took me 6 years of being head of Dittner Institute, where I had the responsibility for the largest budget in history of science made available for research in history of science, before I finally realized the problem with history. It's a simple way to describe it, but it's a lesson everybody needs to learn. When you do historical research, you get a richness that reading secondary sources does not begin to match. And it's actually worse than that. I'm going to give you a little mantra. When anybody writes a secondary source in history, even this man, they put down a very small fraction of what they actually know. My rule of thumb is 5% of what they know, because they know way too much to put it down on the page. If you read that work with slightly different questions from what the author had as questions, you can be very, very badly misled, because the selection of what the person knows is not going to match your question the way it did the original. So increasingly, I've just come where I encourage people to read secondary sources in history. But I really want to encourage and try to do it with my students is get comfortable doing primary source research in history. There is no substitute for it. You're the historian here. Does what I just said make sense?
Is it possible that the reason that
Can't do. A little bit louder.
okay, is it possible that the reason that philosophy of science without history of science is empty, that scientists in the history of science, and I'm getting this partly from DeSalle, or all from DeSalle maybe, they've done a really, really good job of understanding philosophically very deeply the questions we have in philosophy of science, and only those people who are, like those scientists who understood those questions deeply are the ones who ended up contributing very greatly to their field, because there might be practical outcomes of understanding very deeply, philosophically, certain questions. So imagine, 10 scientists physicists maybe, one of whom very, very deeply understands the nature and role of evidence. That person might produce better work, and their work will be infused with this deeper understanding of the nature of evidence. And similarly, some scientists working in space-time theories, they might, maybe there's 10 of them, one of them very deeply understands the philosophical questions that we have about space and time, and the ones that really understand it well are the ones who actually are able to output something that's, scientists call practical. And those are the ones that succeed. So if philosophy of science ignores the history of science, we're ignoring people who actually have a very deep philosophical understanding of issues that we're concerned with, like evidence and the nature of space and time. So I think DeSalle made a good argument for this in his book, and I'm extending it to all areas of philosophy of science. He made an argument for it in terms of not ignoring the history of science with respect to space-time theories, but that's what I now think, because I think, that's probably why history of science is so important, is that the people who've contributed greatly to science really had a deep philosophical understanding, of philosophy of science questions. But maybe I'm wrong. I was just wondering what you thought about that.
So I wasn't able to hear the
Oh.
last little bit. But I'm thinking there might be two ways of reading what you're saying. So one is just, well, when you want to do really good philosophy, what you want to do is is look at the best philosophers and see what they have to say and learn from them. And unfortunately, the best philosophers don't publish in philosophy journals. They've published in science journals. And so that's where we should look for those philosophers. So we don't actually need the history of science. We're still just looking at philosophers. But the other way of reading it is that there's actually something about the business of doing science that puts the best philosophers in a good position to have great philosophical ideas or have better philosophical ideas. So I'm wondering which.
I think I'm wondering whether being philosophically deep and knowing the science of your time very well makes you better at coming up with theories that are in the end very successful. So when we read the giants of science, they're more likely to be people who actually have very deep philosophical understanding of the things that philosophers care about. So if we ignore their work, then we're actually even ignoring philosophical insights that they've made, which are maybe not very explicit much of the time. So I'm going to come up with a hypothetical example, but maybe someone who understands the nature of evidence deeply but doesn't write about it, nevertheless, that contributes to their work in science, as long as they know, as long as they're good scientists in other respects. I don't know. It's just a hypothesis.
Right.
Well, Richard Feynman, a pretty good physicist.
Can you
Some
speak
books
up?
about philosophy of science, it's crap.
Yeah.
So it doesn't always work. I mean, there were some great scientists who were deeply trained philosophically and had philosophical interests, and there are other ones that, are still great scientists. So I don't think, it would be nice if what you said is true,
Okay.
but I don't think it is.
Okay. I don't know enough history of science to know.
I teach a 4-year course, the second half of which is reading the Principia cover to cover. And I start the course by saying, and I repeat it too many times, no one I've encountered has ever thought more carefully about what it is to do science than Isaac Newton. I just have never found anybody who's thought as deeply and as carefully over it.
Yes, yeah, but I also think that
Oh, yeah, of course.
there are lots of other, and so I don't think it's quite as general as your. I think there's some very, very good scientists who are extraordinarily bad at the philosophical lessons they take.
I wonder if something would be said about the sort of science they do. So I agree with you about science. But could someone do what Newton did without also being a philosophical fact, or what Galileo did, or what Darwin did? Because when I think of, I know quite a few physicists who've done really, really good work who are really, really philosophically naive, and it just strikes me as they chose a problem they could solve without a lot of deep insight into the nature of science. But it seems to me that maybe you couldn't do the Principia without thinking very, very deeply about how to turn data into evidence. Any last comments? Or can we
In
wrap up?
fact, Jim brought up a name
Yeah.
earlier
Yes.
that's worth mentioning, Harold Jeffreys. He's of course well known Bayesian, and he wrote a book on scientific method. All of that came out of 20 years of working with travel time data and seismology, and having to learn how to statistically reduce it. That is, his philosophy of science, etc., came out of an extraordinarily long, hard battle with data.
Well, one more I had about the idea of coming up with some kind of formal philosophy of scientific method or science or whatever it is that isn't that sort of what they tried to, isn't that sort of the idea behind philosophy of mathematics and the extent like Wesselian logicism? Isn't that sort of, I mean, I guess we got a really long proof of how 2 + 2 = 4, but whether we got any real insight, how much insight was gained into mathematics by the endeavor is I think some like Lakatoshan people who like Lakatoshan would say suspect. That's my thought.
Whether Estos or Panel.
Oh. Got some mathematics in it?
Yeah.
So there you go.
Nick, did you want to say something?
Yeah, well, it's just that it seems to me that perhaps the comment that Ryan and Professor Kelly have made have not been addressed directly. So I took it to mean something like, sure, history of science is important if we want to do good philosophy of science, but a huge part of the philosophy of science work that cannot be tackled by doing history of science. So if somehow history of science makes us less blind in doing philosophy of science, is there not still a huge blind spot? So how far can we go by doing philosophy of science based on history of science? That would be, maybe you. So I'm trying to put the point that was incendiary, perhaps in an even more incendiary way.
Can I make a comment on that? So one thing Kevin was talking about was the fact that we often pretend to give, we've got a theory and it's got certain consequences, and we don't have to worry about how you find out what the consequences are. And an awful lot of the hard work of science is actually to develop the ways to figure out what the theory predicts. So these are difficult calculational problems. And we have problems that with the series we might want to converge don't converge. And I think that people who face those problems have developed techniques for dealing with those kind of problems that philosophers pay attention to. And I think that one way to pay attention to is to try to come up with some kind of formal theory about this. But in order to even know where to start to come up with a formal theory, I would want to look at what people do and look at the techniques they develop. And similar, I think you're absolutely right that the techniques we can use to discuss scientific methodology have been very crude so far. But if I want, those of us who share the goal of developing more sophisticated techniques, among the resources we have is to look at the history, look at the detailed history of what people actually did. Maybe as a clue to work to developing these formal frameworks we're talking about.
Can I add something?
Yeah.
Again, I've been thinking about this way too long, so that's why I can't shut up. Something philosophers rarely look at that's a gold mine for understanding science is review articles. There are now 28, I haven't checked this in the last 2 years, coming out of Palo Alto. There are annual reviews of 28 different subjects. The one I read too, fluid mechanics, because that's my engineering need, and now I tend to read the one in astrophysics and astronomy because I'm interested in orbital things. What they do is every 3 or 4 years, the same topic recurs. Anybody writing a review article, I've known 2 people to do it. They thought they would do it in a month or 2, and they started looking at the literature, and they spent most of a year. You're actually hired to do this, contracted to do this, with more than a year to spare. Now, there are a lot of bad review articles, but a good review article is a phenomenal thing. The example I'm presently using is Steve Weinberg's book, Cosmology, which came out, about 18 months ago. He came back into the field and couldn't find any one place where you could summarize the state of the field. So he's written a review article as a 300-page book. It is a model of the critical analysis of the state of evidence. You can find them again and again in good review articles, because it's exactly what a scientist has to do when they write a review article, is to figure out what we do know, what we don't know, and why we don't know. So that's a case where I think if philosophers just started looking at some annual review articles, I think they'd be stumped.
I think there are a lot of things, if they looked at them, they'd be stunned.
I can hear.
There are a lot of things that they'd be stunned if they looked at.
Yeah.
And also your example of Harold Jeffries, I mean, he had a lot of clever things to say, but it wasn't necessarily by reading history of science, right?
No, he's doing it.
It was, yeah, he was doing it, but I mean, it wasn't just doing it, I mean, it was developing techniques for doing it that were explicit, right? I mean, he had an understanding of what the fiducial argument was about. That didn't come by poring over Newton's text over and over.
No, that's quite right.
Shall we wrap it up? Thank our panelists.